Hello students, in the last class we discussed about vectors and types of vectors. Now we are going to discuss about the vector operations. Now we have three vector operations, those are addition and subtraction and multiplication. Now division of vector is not possible. So division of vector by vector is not possible. Now we are going to discuss about the addition of vectors. So vector addition. Now in vector addition, I will follow the geometry method. For example, I will take this as vector A bar. For this vector, this is the tail of the vector and this is the head of the vector. Now to this vector, I will add another vector like this. Okay, I will take this vector as for example B bar. Now remember, in vector addition, the head of one vector is in contact with the tail of another vector. Okay, the head of one vector is in contact with the tail of another vector. Now join the tail of first vector to head of first vector. This value or this closing side will use the addition of vectors, that is A bar plus B bar, which is represented with letter R bar. Clear? Which is represented with letter R bar. Now this is the vector addition in geometry form. Clear? It is the vector addition in geometry form. For example, if I take the three vectors like this, for example, I will take this as vector A bar, I will take this as vector B bar, and I will take this as vector C bar. Okay. Now, the head of first vector is in contact with the tail of second vector. The head of second vector is in contact with the tail of third vector. For example, I will take the direction of third vector like this. So I will take the addition of these three vectors, then the addition of these three vectors will give R bar is equal to A bar plus B bar plus C bar. Okay. For example, if I take these two vectors, then this is R bar is equal to A bar plus B bar. For example, if I take these two vectors, this is B bar and this is C bar, then this is R bar is equal to B bar plus C bar. I hope you understood. So this is for three vectors and this is for two vectors, and this is about vector addition. Now next we are going to discuss about vector subtraction or subtraction of vectors. Now let us consider this as vector A bar. I'll consider this as vector A bar, and let us take the projection of vector B bar, or take this as vector B bar. Now I will take the opposite to the vector. Now this is the opposite to the vector. I will take this opposite to the vector as minus B bar. Okay. For example, this is the vector taken in opposite direction. Now the resultant vector is from here to here, that is tail of first vector to head of second vector. Now this is taken as R bar is equal to A bar minus B bar. Now this is the vector subtraction or subtraction of a vector. For example, you can take the vectors like this also. I'll take this as one reference point O. I'll take this point as for example some A. Now the distance from O to A, I will take this vector as for example R1 bar. I will take another point B. I will take the distance from, or the vector from O to point B. I will take this as R2 bar. So I will consider this vector as R1 bar. I will take this vector as R2 bar. Now the resultant, this side is the resultant. This resultant I will take it as R2 bar minus R1 bar. So this vector minus this vector. Okay, I hope you understood. the vector subtraction. Now, in multiplication of vectors, we have two kinds of multiplications, that is dot product as well as cross product. Now we are going to discuss about the vector multiplication. So the next concept is vector multiplication. So we have two kinds of vector multiplications. In the first one is dot product. Or this is also called as scalar product. Now take two vectors. This is vector a bar and I will take another vector. This is vector b bar. Now if a bar and b bar are the two vectors, and if the angle between the two vectors is theta, okay, if a bar and b bar are the two vectors, then angle between the two vectors is taken as theta, then according to the dot product or scalar product, you can take this as a bar dot b bar is equal to ab cos theta, and it is defined as clear, and it is defined as the product of magnitude of two vectors and cosine of angle between them. So this is the dot product of two vectors. Okay, so I'll take scalar product or dot product of two vectors. In dot product or scalar product of two vectors, if you take the dot product a bar dot b bar, that is taken as ab cos theta. Now here a bar is a vector and b bar is a vector. So a bar and b bar are the vectors and a and b are the magnitudes of vectors. So a and b are magnitudes of vectors, a bar and b bar. So a and b are the magnitudes and a bar and b bar are the vectors. Now next we are going to discuss about the properties of dot product. The first property of the dot product is it obeys commutative law. So what is the commutative law means? A bar dot b bar is equal to b bar dot a bar. So this is the commutative law. And remember, it obeys distributive law. So that is a bar dot b bar plus c bar is equal to a bar dot b bar plus a bar dot c bar. For example, if you take dot product, the dot product is a bar dot b bar is equal to ab cos theta. If you take theta as 0, for example, if vector a and vector b are in same direction, so if vector a and vector b are in same direction, then theta is equal to 0. So if theta is equal to 0, if both the vectors are in same direction, then a bar dot b bar is equal to ab cos 0, which is equal to ab, where cos 0 is 1. Let us say if two vectors are perpendicular, I will take this as vector a bar and I will take this as vector b bar. If two vectors are perpendicular, then we have a bar dot b bar is equal to ab cos 90. Then we know that cos 90 is equal to 0. then a bar dot b bar is equal to 0. Now we'll go for the next property. For example, if you take the dot product of a vector with same product, so with same, then it is equal to 1. For example, I'll take the fourth property, that is I cap dot I cap is equal to 1, and similarly j cap dot j cap is equal to 1, and similarly k cap dot k cap is equal to 1. So in dot product, if a vector I cap is multiplied with I cap, then it is 1, j cap multiplied with j cap, it is 1, k cap multiplied with k cap, it is 1. Now similarly, if you take I cap multiplied by j cap, so I cap dot j cap is equal to 0, or else j cap dot I cap is also 0. Why? Because means it follows the commutative law. Similarly, j cap dot k cap is equal to 0, or else k cap dot j cap is equal to 0. Why? Because means it obeys commutative law. And similarly, k cap dot I cap is equal to 0, then I cap dot k cap also equal to 0. This is another property. Now the next property is, for example, if I take a bar as ax I cap plus ay j cap, okay, and I'll take vector b bar as bx I cap plus by j cap, then according to the dot product, a bar dot b bar is equal to ax I cap plus ay j cap dot bx I cap plus by j cap. Now first, with first term multiply ax bx, so ax into bx. Now this is I cap dot this is I cap, so therefore this term will exist. Next, plus first term multiply with the second term, the second vector ax by, but here I dot j, so I dot j is equal to 0, so that term will be 0. Now take with ay and multiply ay bx, this is j dot I, so j dot I equal to 0. Now plus ay by, so I'll take this as ay by, and this is j dot j, so j dot j is 1, so a bar dot b bar value is this value. And the last property, for example, if you take a bar dot b bar, that a bar dot b bar is equal to ab cos theta, or if you want to find out the angle, then cos theta is equal to a bar dot b bar by ab, where a and b are the vectors, a and b are the magnitudes. So a bar b bar are the vectors and a b are the magnitudes. Okay, the next one is cross product, or this is also called as vector product. Now most of the derivations will be based on this vector product or dot product. Okay, now what is the dot product or vector product, cross product or vector product means, if I take this as vector a bar, and if I take this as vector b bar, and if this is the angle between vector a bar and vector b bar, now it is defined as the product of magnitude of two vectors and sine of angle between them, okay. So I will take the cross product like this, a bar cross b bar, that can be taken as ab sine theta. Just try to understand. Whereas in vector product or cross product, there will be one perpendicular to the surface of B bar and B bar. For example, I will expand one line parallel to A bar. I will take one line parallel to B bar. Now it looks like a plane. Now the resultant, for example, if you draw one normal to this plane, that normal will be always in upward direction. That I will take this as a resultant R bar. Okay, that I will take the resultant R bar. Now listen, if you take this R bar is always perpendicular to the plane of A bar and B bar. Now, what do you mean by cross product or vector product? Means it is defined as the product of magnitude of two vectors and sine of the angle between them, and the resultant is perpendicular to the plane of vector A bar and B bar. Okay, now that resultant will consider this as R bar. Clear? That resultant will consider that as R bar. Now if A bar cross B bar means if A crosses on B, okay, A cross B means if A crosses on B, then R bar is in upward direction. So if A falls on B, so A falls on B means anti-clockwise direction. So if two vectors are rotating in anti-clockwise direction, then resultant will be in upward direction. For example, if B crosses on A, that is, if vector B falls on vector A, that is clockwise direction. For clockwise direction, resultant will be in downward direction. So if you take the resultant in downward direction, that is considered as minus R bar. Therefore, it is taken as minus R bar. Okay, so A bar cross B bar, resultant will be in upward direction. B bar cross A bar, resultant will be in downward direction. Now next we are going to discuss about properties of cross product or vector product. So properties. So the first property for the cross product is it doesn't obey commutative law. It doesn't obey commutative law. It doesn't obey commutative law. So what is that means? A bar cross B bar is not equal to B bar cross A bar, but A bar cross B bar is equal to minus B bar cross A bar. So it doesn't obey commutative law. As it is the vector product, so always it gives a vector. Clear? Therefore, vector product is a vector quantity. So it is a vector quantity. Okay, it is a vector quantity. Now the third property is, for example, I will take one cyclic order. In this cyclic order, I will take this as I will take this as J, I will take this as K. Now, if I take I bar or I bar cap crosses I cap. Remember, if you take I cross I, which is taken as 0, similarly J cross J is equal to 0. Similarly, K bar cross K bar or K cap cross K cap, which is taken as 0. And the fourth property, I bar cross J bar is taken as K cap. Okay, so I crosses on J, it will use K. Or else you can write like this also, J cap cross I cap is equal to minus K cap. Similarly, I will take the next one, that is J cap cross K cap. I will take this as I cap. Then you can say that K cap cross J cap is equal to minus I cap. Now next I will take like this, k cap cross I cap. So k cap cross I cap is equal to j cap, or else I will write this as I cap cross k cap is equal to minus j cap. Now the next property I am going to discuss is that is if a bar is taken as ax I cap plus by j cap, then I will take this as b bar is equal to bx I cap plus by j cap. Now according to the cross product, a bar cross b bar, this can be taken as, first you have to take I cap, next you have to take j cap. Okay, first term is ax and this is what take this as ay. So ax and this is ay, and next b bar, for b bar this is bx and by. We are going to discuss the fifth property, that is if a bar is ax I cap plus ay j cap plus az k cap, and b bar is equal to bx I cap plus by j cap plus bz k cap. Now according to the cross product, I will take a bar cross b bar is equal to, I will take this as I cap, I will take this as j cap, I will take this as k cap. Now I will take this as ax, ay and az, and I will take this as bx, by and bz. Now according to the cross product, I will take a bar cross b bar is equal to, first if you take the I cap, then you have to close this row and this column. So if you close this row and this column, what are the four terms means ay, az, by, bz. Then you have to take the cross product of these two, that is ay, bz minus, and I will take the cross product of these two, that is by, az. Okay, so with I it is over. Then go for the j component. So this is the j component. Then you have to take alternative positive and negative, therefore minus j cap into, close this row column and close this row. Then four terms we have ax, az, bx, bz. Then cross multiply these two. Then we have ax, bz minus cross multiply these two. Then we have bx, az. Now you will get alternative positive and negative, therefore first it is positive, therefore next it is negative, therefore next you will get a positive term, that is plus k cap into. So k cap means you have to neglect this row and this column. If you neglect this row and this column, what are the four terms means ax, ay, bx, by. So these are the four terms. Now multiply these two, then ax, by minus bx, ay. And this is the important formula to find out the cross product of two vectors. Now I will go for the next property. Actually I have to discuss this property at first. So that is a bar cross b bar is equal to ab sin theta. AB sin theta. Now this is, I will take it as r bar. Clear, I will take this as r bar. So this is nothing but r bar. For example, if theta is equal to 0, which means that a bar and B bar is in same direction. If two vectors are in same direction, A bar and B bar are in same direction, then A bar cross B bar is equal to AB sine 0, which is taken as 0. So dot product, cross product is 0. If you take theta is equal to 90, that is angle between A bar and B bar is 90 degrees. If you take angle between A bar and B bar as 90 degrees, then you will get A bar cross B bar is equal to AB sine 90. So sine 90 value is 1, that is AB. So A bar cross B bar is equal to AB. Now, if two vectors are perpendicular, then A bar cross B bar is equal to AB, then you will get maximum. If two vectors are in same direction, then theta is equal to 0, then A bar cross B bar is minimum.